This blue color. That's why kids about to sky red and never get black. Barricade blue. You know, Mascara, Barricade. Two identical spheres. Okay. Two identical spheres are suspended on a light inelastic. Are suspended on a light inelastic cotton threads. Sphere T carries a charge of 5.4. Sphere T carries a charge of 5.4 nanocoulomb. 5.4 nanocoulomb. Sphere S carries a charge of minus 8.2 nanocoulomb. Sphere S carries a charge of minus 8.2 nanocoulomb. Right. A drawing is provided. This positive 5.4 nanocoulomb minus 8.2 nanocoulomb is sphere T and S. Potso ya pele e re state the law kapa the principle of quantization of charge. State the principle of quantization of charge. 4.2 calculate the number of electrons added to sphere S. Find number of electrons added on sphere S. 4.3 what type of force is exerted by sphere S on sphere T? What type of force added from sphere S to sphere T? Right, hurry himself. Solution 4.1. State the law of quantization of charge. State the law of quantization of charge. Hearing that quantization law of charge. Ausi Israel. It was along the net electric charge. That law. Hearing that law.
Quantization.
A. The law of quantization of charge.
All charge in the universe consists of integer multiples of charge on one electron.
Cool. Every every charge in the universe all charge in the universe
consists of
integer multiples of electron charge. Every all charge
in
the universe consists of
an
integer
multiple of the charge on one
multiple of charge A
on one electron.
Already bahala ntho tse o tlamehile o di tsebe assembly full of the fatshe o lo bala ntho tse right emereng 4.2 find the number of electrons added on sphere S. Find the number of electrons that are added on sphere S. By just looking at sphere S, in negatively charged, again, among electrons were added. Sphere T, positively charged, electrons were removed. So, about the number of the electrons that were added, which formula are we going to use more to find the number of electrons that were added? The number of electrons that are added equals charge divided by the number on an electron. That's one most important thing that we should know. The number of electrons added, electronic charge, divided by a charge on an electron. So, charge ya runa ke bokae mo ya sphere S when you look at that charge mo. The charge on an electron. Charge ya runa ke bokae? Re nka ile positive kapa re ngola ile negative. That charge ya -8. That is my question. That charge renka ile positive kapa renka ile negative. Why renka ile negative? Aga batla the number of electrons. Are you aware if renka ile negative it will refer a negative number? Renka ile positive, you must take that number as a positive number. You will always take that as a positive. 8,2. But get into nano coulomb. Nano times 10 minus 9. Divide. The charge on an electron. The charge on an electron. The formula sheeting. Formula sheeting the charge on an electron. The charge on an electron. 1,6 times 10 minus 19. The charge on an electron. Minus 1,6 times 10 minus 19. When you calculate the number of electrons that were transferred on a sphere, the charge on a sphere, you will always take as a positive number. You divide by the charge on an electron. Sphere so buanga sonaki S. Charge ya negative 8.2, but when you will take that as a positive. Kinano times 10 minus 9. The charge on an electron, 1,6 times 10 minus 19. This is very, very important. for us to know and for us to know. Highly and highly important. Right. Calculate the value. Kopa that value. Kopa that value. You go that value.
Negative.
The positive. Oh, calculator how? You go we can calculate in film. You go we can calculate in fast. So the number of electrons are equals to the charge divided by a charge on an electron. You will always take your charge as a positive number. You will always take your charge on an electron as a positive number. And then you divide those two and then you get your answer. But I want to know it. Why never formula sheeting number the charge on an electron? Usually, it's actually. Calculate. Uh, 8,2 8.2 times 10 minus 9, and then we are dividing this by the charge on an electron, 1.6 times 10 exponent of minus 19, and this will give you a value of 5,125 times 10 exponent of 10. Remember, which number of electrons? These are the electrons. 5,123 times 10 exponent of 10 electrons that were transferred to sphere S. Be that as it may, what type of a force? What type of a force? What type of a force? What type of a force added from sphere S to sphere T? I don't think it should. Cool. Okay, want to put here. What type of a force is exerted, man? What type of a force is exerted? What type of a force is exerted from sphere S to sphere T? What type of a force is exerted from sphere S to sphere T? What type of a force is that?
Force of attraction.
A force of attraction. A force of attraction. Is that all what we can say? Kappa, is there something else that we can say? Right. Are we here? 4.4. The spheres are brought closer to each other and then separated to their original position. Now, Barry, the spheres touch and allowed to separate Okay. 4.4.1. From which sphere will electrons move from? From which sphere will the electrons move from? T to S or S to T? (4.4.2). State the law of conservation of charge. State the law of conservation of charge. 4.4.3. Use the law of conservation of charge to calculate the new charge on the spheres after separation. Calculate new charge when they touch and separate. And then the last one, use your knowledge of electrostatics to explain the phenomenon below. When the air is dry, your hands feel a small sharp electric shock when you touch a metal door knob after walking along the carpet to the door. Okay, that one I'm not going to write. We will just explain that. Right. Area 4.4.1. The spheres touch and are allowed to separate. From which sphere will the electron move from? T to S or S to T?
S to T.
S to T, because T is running short of electrons. From S to T. 4.4.2. State the law of conservation of charge. Ishebem. Isheb.
Net of charge. The net of charge of an isolated system remains constant.
The net charge.
During the physical process.
The net charge
is the net charge of an.
The net charge of an isolated or closed system. Okay. Remains constant
during any physical process.
During any physical process. Good. Wait till that law, son. 4.4.2.3. Calculate the new charge when the spheres touch and separate. Ready? Q new equals Q1 plus Q2 divided by 2. Q1 positive 5.4 times 10 minus 9. Sphere 2. Renga ile positive kapa renga ile negative. That number ya 8.2.
Positive.
Why positive? Why we tlamehile re nke ile positive? Re nka the way ile nka te, we nka ile negative ile jwalo. Negative 8.2 times 10 minus 9. If ile yani ile negative ne re tlo nka ile negative. If yani ile positive ne ntse re tlo nka ile positive. How calculate a new charge? O nka di charges tseo the way di leng ka teng. And then re fa bokae? Ratlo warere 5.4 and re filwe ke bone re chemistry e mo fa mathata ya mo sokodisa 5.4 times 10 minus 9 minus 8.2 times 10 minus 9. We divide that by 2. Negative 1.4 times 10 minus 9 in coulomb. How this charge is separated, each is separated by this charge. Again? Right. How not state calculate the new charge when they touch and separate. Right. This separated by 1.4. The next question when the air is dry, when air is dry, your hands feel a small sharp electric shock. When the air is dry, your hand feel a small sharp electric charge. Electric charge about electric shock. Okay. When you touch a metal knob, when you touch a metal door knob, okay, after walking along the carpet to the door, after walking along the carpet, along a carpet to the door. Explain this phenomenon. Because again, when the air is dry, okay, your hands feel a small sharp electric shock, okay, when you touch a metal doorknob after walking along a carpet to the door. Explain why. When you have been walking on a dry air and then your body accumulates charge. Your body becomes charged. This charge accumulates in the body. When you touch a metal substance, the electrons are transferred. Came to a pain. Again, Roberto explain this phenomenon. Come on, Jama. When I touch a metal, the electrons are transferred. They are transferred from what? Where? Now you are negatively charged from you to the metal substance. The electrons are transferred from the body, which is your hands in this regard, from your body, your hands, to the metal substance. Come on, someone, your body are discharged, again, and then it discharge by making what? An electric shock. This is a sign here, hurry, your body are discharged. The electrons are being transferred. Because remember, you are touching a metal substance. The electrons are being transferred from the one with a deficiency to the one with an the electrons are being transferred to the one with a deficiency of electrons, which is a metal, from the one with an excess of electrons, which is your body. What's all this process? Hand. After you touch and separate, you will separate with the same equal amount of charge. But this shock is a sign how the electrons are being transferred in the form of a shock. That's exactly what is happening there. This process is exactly taking place. Right. That is that on electrostatic. Right. You go shoot